Welcome to the continued dialogue about exponential functions and equations. And in this video, we're going to begin a conversation about how do we solve exponential equations. And if you'll notice, there's two major ways that we can solve exponential equations. And one is by using like bases, and the other is by using logarithms. So we're going to start by kind of deciding which of these techniques to use when, and then we're going to focus on solving exponential equations by using like bases in this particular video. So one really good way of solving exponential equations is by using the technique of common bases. Okay, and so you can do this only if both sides of the equation can be written as powers of the same base. For example, if you can write both sides of the equation with one specific base, in this case, b is the base. So if you can write b is raised to x plus 5, and that expression is equal to b to the 7th, well, if you can get it into that form, then it's got to be true that those exponents have got to be the same. So x plus 5 would have to equal 7, and then you can go ahead and solve for x, and you know that that would end up being 2. So that is one specific way to solve exponential equations. And another is if you can't write them as powers of the same base, then you can use appropriate logs to clear the exponents. And there's a couple of different ways to do this, but one of those ways is if you've got an equation where b is raised to x and that expression is equal to c, then I can take a log base b of both sides of the equation. And by doing that, the left-hand side, since those bases are the same, the base of the log and the base of the exponent cancel each other out, and you just end up with x is equal to log base b of c. And of course, you could use your change of base formula to take that log base b of c and create a ratio of two logs, log of c divided by log of b. All right, so here's 3 examples of problems that can be solved using common bases. For the first one, we are going to examine the equation and see if both sides can be written as a power of the same base. And in this case, it's a pretty simple equation, and we can say that both sides can be written as powers of 5. Now, when you have this exponential equation going on, you're going to have the variable n, the exponent, on one side in this case. And if you're looking at that expression, always start by the base there and see if both sides of the equation can be written as powers of this base. Okay, so we can definitely say that 625 is a power of 5. And now we have this equation 5 to the x is equal to 5 to the 4th. And we have both sides written as powers of the same base, which means we can just get rid of the bases altogether and equate the exponents. And in this case, we're done. X would be equal to 4. You would want to go ahead and sub that value back into your equation and double check that. Okay, so the next example, we have 4 to the x is equal to 32. And remember I said we want to check and see if both sides of the equation can be written as powers of the base of the exponential expression. So you want to see, can 32 be written as a power of 4? And in this case, no, both sides cannot be written as a power of 4. So we want to look at that 4 a little further and think, what can I write 4 as a power of? What smaller numbers can be raised to a power to actually get us the value of 4? And if you said 2, you'd be right, because 4 is really 2 squared. So we can replace this 4 with 2 squared, And we know that 32 can be written as a power of 2 as well. So we're going to revise our equation to write it in terms of a base of 2. Okay, so now remember that when you have 2 raised to a power and that whole thing is raised to a power, that's really a power of a power. And we multiply those, and so we would end up with 2 to the 2x is equal to 2 to the 5th. And now we have both sides written as powers of a common base. We can get rid of the bases and equate the exponents. So 2x is equal to 5, which means that x would equal 5 halves. And again, always worth it to take that answer, 5 halves, and sub it back into your original equation and double check that you do get this answer out. Okay, here's another example. We have 3 raised to the 1 minus x is equal to 1 over 27. So where we see the x, we have a base of 3. So the first thing we want to check is, can both sides of the equation be written as a power of 3? And we definitely know the left-hand side can because it's already there. But think about that right-hand side. Can 1 over 27 be written as a power of 3? Well, we definitely know 27 can, right? Because 27 is 3 cubed. But what's going to make that go down to the denominator? That's going to be a negative exponent. So we can say that 1 over 27 is the same as 3 to the negative 3rd power. And then we've got both sides written as powers of the same base. We can cancel your bases and then equate the exponents. 1 minus x is equal to negative 3, which means negative x is equal to negative 4. And then dividing out a negative 1 on both sides, we would have x is equal to 4. Again, take the time and sub it back in and make sure that you get the output that you really want. Okay, a few more examples. This first example on this slide, we have 6 raised to the x minus 3 over 4 is equal to the square root of 6. So looking at where our variable is, it's on the left-hand side there, and the base is 6. So we want to know, can this right-hand side be written as a power of 6? And probably some of you remember that the square root of 6 can also be written as 6 to the 1/2 power. So yes, they both can be written as powers of 6. And since both sides now are written as powers of a common base, we can definitely cancel the bases, equate the exponents, and then solve for our variable. So how would you solve this equation? You would definitely get rid of the denominator on the left-hand side by multiplying both sides by 4. That would just cancel out the denominator on the left, but 4 times 1/2 is equal to 2. And then isolate x by adding 3 to both sides, and x is equal to 5. Okay, another example here, and our variable is a power of 9. So we want to think, can both sides be written as a power of 9? And the answer to that is yes, but there's an easier way. Because we know 9 can be written as a power of 3, and we know that this right-hand side is definitely a power of 3. So we definitely know both sides can be written here as powers of 3. So thinking about 9, 9 is 3 squared, so we're going to replace this 9 with 3 squared. And then on the right-hand side, what power of 3 is the entire right-hand side? And again, it's easier to kind of think about, well, what power of 3 is the denominator here? And you know that the denominator is the 1/3 power, but then what makes it go to the denominator? And that's going to be a negative exponent. So as we rewrite this, we end up with 3 squared to the x is equal to 3 to the negative 1/3. And then we want to get rid of these parentheses so that the 3 is just raised to a single power. So 3 to the 2x is equal to 3 to the negative 1/3. Okay, so get rid of those bases, equate your exponents, and then solve for x. Now, you may think of negative 1/3 as being divided by 2 to get our final answer, but it's really easier when you have a fraction on the other side to think about isolating the x by multiplying by the reciprocal. So if I multiply both sides of this equation by 1/2, it's easier to do the calculation, and we would end up with x is equal to negative 1/6 here. Again, check it. Go back and check it. All right. So this final example, we're looking at e is raised to the x plus 4, and that expression is equal to e is raised to the 2x. And so in this example, can you write both sides of the equation as, okay, e to some power? And of course we can. What is an alternate way to express this expression so that it's just e to some power? Well, what would make that e to the 2x go to the denominator? That would be a negative 2x. And so then you can drop your bases and equate your exponents and solve for x. So bring that negative 2x to the left and the 4 to the right, and then divide out the 3, and you would get x is equal to negative 4/3. In the next installment, we're going to pick up the conversation about solving exponential equations, but this time we will use logarithms in order to solve the equations that we're given. I'll see you next time.